Hi, I'm Paul, and this is an overview of how I approached sound for this horror template. Really an excuse for me to do some sound design for horror games, because I love horror games, and also a way to show my workflow for 3D audio in Unreal and my sound design process. The level is very simple, but it makes heavy use of the Steam Audio integration, which uses geometry-based reflections, which is very useful for immersive gaming and VR. I wanted to create a very subtle soundscape, so this could function as a base for more elements. If it was in a full project, you maybe have a lot more interactables and so on. So this is just the base layer as like a starting point. I'll show a quick playthrough, and I'll break down some of the individual sounds and triggers I created. So now taking a look at some of the elements in there. The torches were created with a few different layers of recorded sounds, as shown here. Blowing and whistling across the microphone in several passes also became the basis of the exterior wind sound you hear by the windows. The bass drone you can hear throughout the level as a kind of general bass layer to tie all the emitters together and to set an ambience was actually made from a generator from around the back of a bar, and a vent panel with some really flappy flaps which was pitched right down and layered. On top of this bass, I added some randomly triggered emitters and some additional ambience layers, which I got from recording my flat's annoyingly noisy doors and latches, which in this case actually came in very handy. The crypt also had some gaps for coffins, but I thought it'd be more interesting for this example to have them sound like they had an opening behind them, as if they've cracked open into an underground hidden cavern full of running water. Luckily, I've got some pipes behind my flat, and a kindly neighbour happened to flush their toilet while I was recording, so thank you, stranger. I only had a short clip of this because, apparently it didn't use much water, so I used Ableton's granulator to chop up and loop this sample, which actually enhanced the texture. Sorry. And that's the thing I love about sound design, and audio design in general, is that it's not about creating a literal version of the thing you're trying to convey, like a one-to-one recording, but about telling a lie that conveys the truth behind it. For instance, in Lord of the Rings, the sound of the Balrog, they layered in the sound of a concrete block being dragged along a stone surface for the roar. And once you know this, you'll hear it every time, but you don't notice it the first time. And it might not be made of stone, but the character shines through in a sound that perfectly portrays this ancient creature stalking the dwarven ruins, having become a part of that dark chasm it exists in. I'm getting a little off track, but I hope that makes sense. Coming back to the project, I used Unreal's native engine with custom spatialization for the implementation. For certain triggerable sounds, I used things like this, with some custom blueprint logic built in. So this trigger box, for instance, what it does is at the start of the level, it will get a reference to the player. It will then create an array out of all the spawners that I've placed. So these are individual assets, individual actors, and it will create an array out of those. It will then initialize a second array, which is set to the size of the number of these emitters that it finds. Then when the actor overlaps it, it'll check to see if this is a player. If it is, it will then do a loop of the spawners for each array element, and it will get the distance from it to the player. And then down here, when it's completed this loop, it'll check for the lowest one, so it'll check for the one that's closest to the player. Then it'll get the audio component on that spawner and then play back a sound on it here. For any sounds that occurred multiple times, I would use randomization inside Unreal. So for instance, these looping containers for the bass torch layer are randomized. The volume is then modulated and mixed with a crackle layer, which again has the volume altered and then is finally output, and these are just triggered on standard emitters. So that's a brief summary of my workflow without going too deep into the actual spatialization process and optimization of reflection counts and lighting. Well, I'm super grateful that people post free content on the Unreal Marketplace like this level to experiment with. Could we please spend some time optimizing them for PCs that don't run NVIDIA Titans? I mean, to be fair, it does encourage you to step outside your own discipline, and I would encourage people to experiment with these things because it helps you understand the development process as a whole. So thanks, I guess. And thank you for watching. If you have any questions or are looking for audio for your next project, please feel free to reach me at contact@pauldb.xyz. Thanks.